Nevado del Ruiz. The Nevado del Ruiz, also known as La Mesa de Herveo, or Cuman Day in the language of the local pre-Columbian indigenous people, is located on the border of the departments of Caldas and Tolima in Colombia, about 129 kilometers west of the capital city Bogotá. It is a stratovolcano composed of many layers of lava alternating with hardened volcanic ash and other pyroclastic rocks. Nevado del Ruiz has been active for about 2 million years, since the Early Pleistocene or Late Pliocene, with 3 major eruptive periods. The current volcanic cone formed during the present eruptive period, which began 150,000 years ago. The volcano usually generates Vulcanian to Plinian eruptions, which produce swift-moving currents of hot gas and rock called pyroclastic flows. These eruptions often cause massive lahars, which pose a threat to human life and the environment. The impact of such an eruption is increased as the hot gas and lava melt the mountain's snowcap, adding large quantities of water to the flow. On November 13, 1985, a small eruption produced an enormous lahar that buried and destroyed the town of Armero in Tolima, causing an estimated 25,000 deaths. This event later became known as the Armero tragedy, the deadliest lahar in recorded history. Similar but less deadly incidents occurred in 1595 and 1845, consisting of a small explosive eruption followed by a large lahar. The volcano is part of Los Nevados National Natural Park, which also contains several other volcanoes. The summit of Nevado del Ruiz is covered by large glaciers. The volcano continues to pose a threat to the nearby towns and villages, and it is estimated that up to 500,000 people could be at risk from lahars from future eruptions. Nevado del Ruiz, which lies about 129 kilometers west of Bogotá, is part of the Andes mountain range. The volcano is part of the Ruiz-Tolima volcanic massif, a group of 5 ice-capped volcanoes which includes the Tolima, Santa Isabel, Quindio, and Makin volcanoes. The massif is located at the intersection of 4 faults, some of which still are active. Nevado del Ruiz lies within the Pacific Ring of Fire, a region that encircles the Pacific Ocean and contains some of the world's most active volcanoes. It is the 3rd most northerly of the volcanoes, lying in the North Volcanic Zone of the Andean volcanic belt, which contains 75 of the 204 Holocene-age volcanoes in South America. The Andean volcanic belt is produced by the eastward subduction of the oceanic Nazca Plate beneath the South American continental plate. As is the case for many subduction zone volcanoes, Nevado del Ruiz can generate explosive Plinian eruptions with associated pyroclastic flows that can melt snow and glaciers near the summit, producing large and sometimes devastating lahars. Like many other Andean volcanoes, Nevado del Ruiz is a stratovolcano, a voluminous, roughly conical volcano consisting of many strata of hardened lava and tephra including volcanic ash. Its lavas are andesitic-dacitic in composition. The modern volcanic cone comprises 5 lava domes, all constructed within the caldera of an ancestral Ruiz volcano: Nevado el Cisne, Alto de la Laguna, La Alta, Alto La Pirana, and Alto de Santano. It covers an area of more than 200 square kilometers, stretching 65 kilometers from east to west. The mountain's broad summit includes the Arenas crater, which is 1 kilometer in diameter and 240 meters deep. Nevado del Ruiz, as its neighbors to the southwest Nevado el Cisne and Nevado de Santa Isabel, is located over the Palestina Fault that crosscuts the underlying El Bosque batholith, dated at 49.1 plus or minus 1.7 Ma. The summit of the volcano has steep slopes inclining from 20 to 30 degrees. At lower elevations, the slopes become less steep, their inclination is about 10 degrees. From there on, foothills stretch almost to the edge of the Magdalena River, north of the volcano, and the Caucar River to the west. On the 2 major sides of the summit, headwalls show where past rock avalanches occurred. At times, ice on the summit has melted, generating devastating lahars, including the continent's deadliest eruption in 1985. On the volcano's southwest flank is the pyroclastic cone La Alta, which is not currently active, but may have erupted in historical times. The summit of Nevado del Ruiz is covered by glaciers, which formed over many thousands of years, and have generally retreated since the last glacial maximum. From 28,000 to 21,000 years ago, glaciers occupied about 1,500 square kilometers of the Ruiz-Tolima Massif. As late as 12,000 years ago, when the ice sheets from the last glacial period were retreating, they still covered 800 square kilometers. During the Little Ice Age, which lasted from about 1600 to 1900 CE, the ice cap covered approximately 100 square kilometers. Since then the glaciers have retreated further because of atmospheric warming. By 1959, the Massif's glaciated area had dropped to 34 square kilometers. Since the 1985 eruption, which destroyed about 10% of the summit ice cover, the area of Nevado del Ruiz covered by glaciers has halved from 17 to 21 square kilometers just after the eruption to about 10 square kilometers in 2003. The glaciers reached altitudes as low as 4,500 meters in 1985 but have now retreated to elevations of 4,800–4,900 meters. The ice cap is approximately 50 meters thick on average. It is thickest in parts of the summit plateau and under the Nereides Glacier on the southwestern slopes, where it is as deep as 190 meters. Glaciers on the northern end, to a lesser extent, the eastern slopes lost the most ice in the 1985 eruption, and therefore reach only up to 30 meters deep. The deep ice covering the summit plateau may hide a caldera. 5 domes ringing the summit plateau have emerged as the ice has retreated. The meltwater from the glaciers drains primarily to the Caucar River and Magdalena River via the western and eastern flanks of the volcano, respectively. Runoff from these glaciers and those on the surrounding volcanoes is a source of fresh water for 40 surrounding towns, and Colombian scientists and government officials are concerned about the town's water supply should the glaciers melt completely. Nevado del Ruiz is generally poorly forested because of its high elevation, and its forest cover decreases with increasing elevation. At lower elevations, well-developed mesic forests are present. Above these but below the tree line, parts of the volcano are covered with dwarf forests 3–8 meters high. Above the tree line, in the Paramo zone, the vegetation is dominated by plants such as bunchgrass and espalicia. Regional vegetation consists of different families of woody plants, including Rubiaceae, Leguminosae, Melastomataceae, Lauraceae, and Moraceae. Flowers such as Polypodiaceae sl, Araceae, Poaceae, Asteraceae, Piperaceae, and Orchidaceae are also present in the region. Animals living on the volcano include the mountain tapir and spectacled bear, both of which are designated as threatened. Other animals inhabiting the surrounding region include the rufous-fronted parakeet, bearded helmet crest, and Herveo plump toad. The volcano is home to 27 species of birds endemic to Colombia, with 14 of these species confined to the region around the volcano. 15 bird species in the area are considered threatened. Nevado del Ruiz is one of several stratovolcanoes within Los Nevados National Natural Park, a national park located west of Bogotá in the center of the Colombian Andes. The park is a popular tourist destination and contains several tourist shelters. The slopes of the volcano are used for winter sports, and nearby Lake Otun offers trout fishing. A number of commercially operated spas can be found nearby. In 1868–1869, German geologists Wilhelm Reis and Alfons Stubble were the first to attempt to climb Ruiz. In 1936, W. Cunet and Augusto Ganser Biaggi made the first successful ascent, partly by ski. They repeated the ascent in 1939. The first eruptions of Nevado del Ruiz occurred about 1.8 million years ago at the beginning of the Pleistocene epoch. 3 primary eruption periods in the history of the Massif have been identified: ancestral, older, and present. During the ancestral period between 1 million to 2 million years ago, a complex of large stratovolcanoes was created. Between 1.0 million and 0.8 million years ago, they partially collapsed, forming large calderas. During the older period, which lasted from 0.8 million to 0.2 million years ago, a new complex of large stratovolcanoes developed. Once again, explosive summit calderas formed from 0.2 million to 0.15 million years ago. The present period began about 150,000 years ago and involved the development of the present volcanic edifice through the emplacement of lava domes made of andesite and dacite inside older calderas. During the past 11,000 years, Nevado del Ruiz passed through at least 12 eruption stages, which included multiple slope failures, pyroclastic flows and lahars leading to partial destruction of the summit domes. During the past several thousand years, eruptions of the volcanoes in the Ruiz-Tolima Massif have mostly been small, and the pyroclastic flow deposits have been much less voluminous than during the Pleistocene. Since the volcano's earlier eruptions are not recorded, volcanologists have used tephrochronology to date them. During recorded history, eruptions have consisted primarily of a central vent eruption followed by an explosive eruption, then lahars. Ruiz's earliest identified Holocene eruption was about 6,660 BC, and further eruptions occurred in 1,245 BC plus or minus 150 years, about 850 BC, 200 BC plus or minus 100 years, 350 AD plus or minus 300 years, 675 AD plus or minus 50 years, in 1350, 1541, 1570, 1595, 1623, 1805, 1826, 1828, 1829, 1831, 1833, 1845, 1916, December 1984, March 1985, September 1985, July 1991, and possibly in April 1994. Many of these eruptions involved a central vent eruption, a flank vent eruption, and a phreatic explosion. Ruiz is the second most active volcano in Colombia after Glaciers. On the morning of March 12, 1595, Nevado del Ruiz erupted. The episode consisted of 3 Plinian eruptions, which were heard up to 100 kilometers from the summit of the volcano. A large amount of ash was ejected, which completely darkened the surrounding area. The volcano also erupted lapilli and pumice bombs. In total, the eruption produced 0.16 km3 of tephra. The eruption was preceded by a large precursor earthquake 3 days before. The eruption caused lahars, which traveled down the valleys of the nearby Guali and Lagunillas rivers, clogging up the water, killing fish, and destroying vegetation. More than 600 people died as a result of the lahar. The 1595 eruption was the last major eruption of Nevado del Ruiz before 1985. The 1595 and 1985 eruptions were similar in many respects, including in the chemical composition of the erupted material. On the morning of February 19, 1845, a large earthquake resulted in a substantial mud flow. This mud flow flowed down the valley of the Lagunillas River for approximately 70 kilometers, spilling out of the river channel and killing much of the local population. After reaching an alluvial fan, the mud flow split into 2 branches. The larger portion of it joined the Lagunillas River and flowed into the nearby Magdalena River, while the smaller portion was diverted by hills in front of Lagunillas Canyon, turned 90 degrees to the north until it reached the Sabandija River, and then flowed east with the Sabandija River, until it rejoined the other branch of the mud flow at the junction of the Sabandija and the Magdalena. It is estimated that 1,000 people were killed in the mud flows. Beginning November 1984, geologists observed an increasing level of seismic activity near Nevado del Ruiz. Other signs of a forthcoming eruption included increased fumarole activity, deposition of sulfur on the summit of the volcano, and small phreatic eruptions. In the latter, hot magma came in contact with water, resulting in explosions as the water was almost instantly turned into steam. The most notable of these events was an ash ejection on September 11, 1985. The activity of the volcano decreased in October 1985. The most likely explanation of the events is that new magma rose into the volcanic edifice before September 1985. An Italian volcanological mission analyzed gas samples from fumaroles along the arena's crater floor and proved them to be a mixture of carbon dioxide and sulfur dioxide, indicating a direct release of magma into the surface environment. The mission's report, delivered on October 22, 1985, judged the risk of lahars to be very high. The report proposed various simple preparedness techniques to local authorities. In November 1985, volcanic activity once again increased as magma neared the surface. The volcano began releasing increasing quantities of gases rich in sulfur dioxide and elementary sulfur. The water content of the fumaroles gases decreased, and water springs in the vicinity of Nevado del Ruiz became enriched in magnesium, calcium, and potassium, which were leached from the magma. The thermodynamic equilibration temperatures, corresponding to the chemical composition of the discharged gases, were from 200 degrees C to 600 degrees C. The extensive degassing of the magma caused pressure to build up inside the volcano, which eventually resulted in the explosive eruption. At 3:06 p.m., on November 13, 1985, Nevado del Ruiz began to erupt, ejecting dacitic tephra more than 30 kilometers into the atmosphere. The total mass of the erupted material was 35 million tons, only 3% of the amount that erupted from Mount St. Helens in 1980. The eruption reached a value of 3 on the Volcanic Explosivity Index. The mass of the ejected sulfur dioxide was about 700,000 tons, or about 2% of the mass of the erupted solid material, making the eruption atypically sulfur-rich. The eruption produced pyroclastic flows that melted summit glaciers and snow, generating 4 thick lahars that raced down river valleys on the volcano's flanks. It also destroyed a small lake that was observed in Arena's crater several months before the eruption. Water in such volcanic lakes tends to be extremely salty and contain dissolved volcanic gases. The lake's hot, acidic water significantly accelerated the melting of the ice. This effect was confirmed by the large amounts of sulfates and chlorides found in the lahar flow. The lahars, formed of water, ice, pumice, and other rocks, mixed with clay as they traveled down the volcano's flanks. They ran down the volcano's sides at an average speed of 60 km per hour, eroding soil, dislodging rock, and destroying vegetation. After descending thousands of meters down the side of the volcano, the lahars were directed into all of the 6 river valleys leading from the volcano. While in the river valleys, the lahars grew to almost 4 times their original volume. In the Gwali River, a lahar reached a maximum width of 50 meters. One of the lahars virtually erased the town of Armero in Tolima, which lay in the Lagunilla River Valley. Only 1/4 of its 28,700 inhabitants survived. The second lahar, which descended through the valley of Chinchina River, killed about 1,800 people and destroyed about 400 homes in the town of Chinchina, in the department of Caldas. In total, over 23,000 people were killed and approximately 5,000 were injured. More than 5,000 homes were destroyed. The Armero tragedy, as the event came to be known, was the second deadliest volcanic disaster in the 20th century, being surpassed only by the 1902 eruption of Mount Pelee, and is the 4th deadliest volcanic eruption in recorded history. It is also the deadliest known lahar, and Colombia's worst natural disaster. A young girl named Omaira Sanchez became a worldwide symbol of the disaster after images of her trapped under the debris of her former home, after the eruption made the news worldwide. The loss of life during the 1985 eruption was due partly to the fact that scientists did not know precisely when the eruption would occur, and the authorities would not take costly preventative measures without clear warnings of imminent danger. Because the volcano's last substantial eruption occurred more than 140 years earlier, it was also hard for many to accept the danger the volcano presented. Locals even called it the sleeping lion. Hazard maps showing Armero would be completely flooded after an eruption were distributed more than a month before the eruption, but the Colombian Congress criticized the scientific and civil defense agencies for scaremongering. Local authorities failed to alert people to the seriousness of the situation, with Armuro's mayor and a priest both reassuring the populace after an ash eruption on the afternoon of November 13 and the consequent ash fall early that evening. Another factor was the storm that hit that evening, causing electrical outages and hindering communications. Civil defense officials from 4 nearby towns tried to warn Armuro the lahar was approaching in the hour or so before it reached Armuro, but failed to make radio contact. Scientists later looked back to the hours before the eruption and noticed that several long-period earthquakes, which start out strong and then slowly die out, had occurred in the final hours before the eruption. Volcanologist Bernard Chouet said that, "The volcano was screaming, 'I'm about to explode,' but the scientists who were studying the volcano at the time of the eruption were not able to read this signal." The volcano continues to pose a serious threat to nearby towns and villages. The most likely hazard is small volume eruptions, which might destabilize glaciers and trigger lahars. Despite the significant retrenchment of the volcano's glaciers, the volume of ice atop Nevado del Ruiz and other volcanoes in the Ruiz-Tolima Massif remains large. Melting merely 10% of the ice would produce mudflows with a volume of up to 2 million cubic meters, similar to the mudflow that destroyed Armuro in 1985. Such lahars can travel up to 100 kilometers along river valleys Indiana a matter of few hours. Estimates show that up to 500,000 people living in the Comiima, Chinchina, Coelho Tosh, and Guali valleys are in danger, and 100,000 of these are considered to be at high risk. Lahars poses a threat to nearby towns of Honda, Mariquita, Ambalima, Chinchina, Herveo, Villa Hermosa, Salgar, and La Dorada. Although small eruptions are more likely, the 2-million-year eruptive history of the Ruiz-Tolima Massif includes numerous large eruptions, indicating that the threat of a large eruption cannot be ignored. A large eruption would have more widespread effects, including the potential closure of Bogotá's airport due to ashfall. As the Armuro tragedy was exacerbated by the lack of early warnings, unwise land use, and the unpreparedness of nearby communities, the government of Colombia created a special program to prevent such incidents in the future. All Colombian cities were directed to promote prevention planning in order to mitigate the consequences of natural disasters, and evacuations due to volcanic hazards have been carried out. About 2,300 people living along 5 nearby rivers were evacuated when Nevado del Ruiz erupted again in 1989. When another Colombian volcano, the Nevado del Huila, erupted in April 2008, thousands of people were evacuated because volcanologists worried that the eruption could be another Nevado del Ruiz. In 2006, heavy rains on Ruiz sent a mudslide down the Chinchina River, killing 9 youths aged 12-19 on a scouting expedition near the volcano. During September and October 2010, Ingiominas noted gradual increases in seismic activity near the Arenas crater. Sulfurous odors and phreatic eruptions reported at Nevado del Ruiz prompted an alert level of yellow on October 1. Chemical analysis of the volcano demonstrated deformative changes and geochemical alterations. Over the next 4 months, a smattering of long-period earthquakes, considered pseudo-tornillo events, raised worries that the volcano might erupt. In 2010, tilt increased, and on average 890 volcanic tremors were recorded monthly, roughly 8 times as many as had been recorded from 2009-2010. 2010 marked the beginning of increases in sulfur dioxide emissions accompanying small eruptions at the volcano, which both peaked in February 2012, correspondent to a dramatic increase in earthquakes. Scientists flying over the volcano on March 8, 2012 noted fresh ash deposits on the east flank of the volcano near the crater, likely from an phreatic eruption on February 22. Later that day, a small ash plume erupted from the crater. By March 13, scientists detected ash deposits at the head of the Guali River. After seismicity continued to increase, the alert level was raised to orange, and in April Nevado's National Natural Park Authority closed the reserve, fearing lahars and ashfall hazards. The sudden activity peak in March did not culminate in a major eruption, and activity declined enough that the alert level was lowered to yellow on May 3. On May 29, seismicity rapidly increased, and the alert level was restored to orange because ash fell into more than 20 nearby communities. Over the next few months ash fell frequently until earthquakes increased again in June. Because of the severity of these tremors, evacuations were ordered by the Emergency Committee of Caldas on news media for 1,500 people near the volcano. The alert level was raised to red, indicating an imminent major volcanic event, and an eruption 7.5 kilometers in diameter took place on July 2, 2012, continuing intermittently until the end of August. Ash plumes and sulfur dioxide emissions recurred until January 2013. Through the beginning of July 2013, ash fall took place at Nevado del Ruiz a few times per month. On July 11, 2013, there was a relatively large explosion, followed by inactivity until August, when emission of ash resumed, continuing intermittently until April 2014. Reports of ash fall stopped until October 2014. In November 2014, earthquakes were recorded, and volcanic ash was observed near the summit. Ash fall reached local communities within a 19 miles radius of Nevado del Ruiz multiple times each month until December 2015. A lava dome was extruded from August to the end of October in 2015, coinciding with thermal anomalies increasing near the summit crater at the end of the same year. According to the Global Volcanism Program, the last documented eruption at Nevado del Ruiz took place in 2017. However, reports from the Servicio Geológico Colombiano Observatory at Manizales through the end of October 2018 suggested earthquakes near the volcano, with phreatic eruptions ejecting water vapor, volcanic ash, and volcanic gases up to 0.93 miles over its crater.